The final measurement mode I want to talk about is single photon counting kinetic mode, which is used to measure the longest lifetimes. The idea of the experiment in kinetic mode is quite different to TCS/PC and MCS. The excitation source for the sample is now a continuous wave source. So most commonly, this is provided by the continuous xenon lamp of the FLS1000, which is passed through the excitation monochromator to excite the sample with your chosen wavelength. And there's various types of kinetic mode measurements you can do. So one option is you can keep the sample constantly illuminated throughout the measurement. So this could be useful, for example, if you're looking at the degradation of your sample over time. You can monitor the change in photoluminescence intensity as a function of exposure time to the excitation light. Another option is that there's a computer-controlled shutter, and this shutter can be told to engage after a set amount of time. So you can excite your sample and charge it up for a certain length of time, then close the shutter, and then monitor the photoluminescence decay after the excitation light has stopped. Kinetic mode is ideal for measuring very long lifetimes, such as persistent luminescence. So the example here shown on the left is the persistent luminescence from a phosphor measured using kinetic mode. The sample was exposed to the excitation light for 5 minutes, which was set up using the fluorical software control of the shutter. You can set the shutter to always open, closed, or timed. So here it was set to 5 minutes. And then after 5 minutes, the shutter was closed and the persistent luminescence decays measured. And they were measured as a function of different excitation wavelengths to see what influence the excitation wavelength had on the decay profile.